Good afternoon. My name is Akash Solman and I'll be presenting my project demonstration based on the topic the automated skin cancer detection system using the ABCD diagnostic measure. Now we know that skin cancer is a prevailing affliction which presents itself in the form of tumors, which are otherwise known as the untoward growth of skin tissues present in our body. The rate at which these growths often occur are unpredictable, often exhibiting varying degrees of reach and afflicted regions, including internal organs in the body with largely differing rates of growth, as well as manifesting physically on our skin. This makes it very difficult to treat the disease once it's already made its quick progression through the body. This instills the need for early detection and treatment, where it is far easier and less invasive to treat the cancer when it is in its infancy stages. Now, this need for early detection is compounded with the aggressive nature of the deadliest form of skin cancer, also known as melanoma. This is also the leading form of skin cancer to produce mortality in most cancer cases which are recorded. Thus, by making use of a diagnostic measure named the ABCD measure, it's possible for patients to be aware and vigilant for visual cues or markers which present itself on the skin in the early stages, so that they may be able to make responsive actions to visit their doctor or clinic for immediate attention if they find physical markers of melanoma on their skin. Now, what exactly does the ABCD rule for cancer detection state? Melanoma, when it manifests on our skin, presents several different characteristics, of which asymmetry. The skin lesions present on our skin are often asymmetric about the different axes of symmetries dividing the melanoma into several parts. It also exhibits an irregular border with abrupt cutting off borders, and it also exhibits a number of different colors rather than one color. So the different colors could be dark brown, light brown, red, gray, blue, black, white. All of these colors contribute to the likelihood that the skin lesion is a melanoma. Also, when melanoma manifests on our skin, it's often in size and in diameter greater than 6 millimeters, while there are melanomas which exist in size greater than lesser than 6 millimeters. We'll consider that as we continue forward. Now, if our lesion exhibits asymmetry about one axis or about two axes, then we assign a value of 1 or 2. If it exhibits asymmetry about 1 or 2 axes, so the A parameter varies from 0 to 2. We vary the B parameter from value from 0, 1 to 8, depending on the number of blocks which define the ragged nature of the lesion in terms of smaller blocks. We define the color parameter in terms of each of the colors present in the lesion. The 6 possible colors are white, red, light brown, dark brown, blue-gray, and black. Depending on the number of colors present, the C parameter varies in values from 0 to 6. And as I stated earlier, the melanoma size and diameter varies in values from small, from 0 to 6 millimeters. And for any melanoma which is above 6 millimeters, it is a very strong likelihood that it is a threat, and thus is assigned a value of 5, the maximum value. Now, using these ABCD parameters which we've just defined, we can combine them, weighting them in terms of the influence and their characteristics when they manifest, and determine a weighted score which would give us an idea of the threat that is imposed by the current skin lesion on our skin, also known as the dermatological score. The total dermatological score gives us an aggregate score which, if it falls in the range of greater than 5.45, the lesion found on our skin is most likely cancerous and requires immediate medical attention. If it is less than 4.75, the lesion found is benign, non-cancerous, and if it lies between 4.75 and 5.45, it's suspicious, and it is still highly recommended that we seek immediate medical attention. Now that we know what the ABCD criterion is, we can move on to the project objective, which is to make use of MATLAB to develop an automated detection system utilizing the ABCD criterion and the individual parameters described to determine the total dermatological score for the lesion for different images, and thus determining the weight on the score for which the skin lesion present on our skin can be assigned. This is our system design and methodology. We have our skin lesions, which are present at the top, from which we acquire images of our skin lesions by making use of simple methods such as video or cameras, or our advanced instruments like our microscopy, tissue, video, etc. Using the images that we receive from our acquisition techniques, we have three different systems. The image segmentation system, which is responsible for pre-processing, for contrast enhancement, and for correction and for edge detection and smoothing of the image, to allow for us to determine the A and B parameters using the image segmentation system by using the canny edge detection and the watershed segmentation. The wavelet analysis system, on the other hand, makes use of the wavelet transform and decomposition to determine the percentage of skin covered by the skin lesion, and thus determining the diameter or the D value, the D parameter of our ABCD. And the fuzzy inference system is responsible for determining the color histogram or the average color calculation to determine the colors which are present in the skin lesion. These are some of the examples of the likely skin lesions that we will come across in our day-to-day lives. So using these as our input images to our system, we determine and extract the ABCD parameters for each of the images and determine the total score for each image and assess whether it is cancerous or not. So going by the results of the images which I just demonstrated, we can see that our detection system works with a very good accuracy, having made the correct decision 8 out of 10 times while only misdiagnosing twice. In one occasion where it misdiagnosed a benign melanoma as cancerous and a cancerous melanoma as being benign. So what are the conclusions? The use of the ABCD parameter can be used as diagnostic to determine if a lesion could be potentially cancerous in nature, and since it achieves a good accuracy as we saw in our sample space of lesions, the feature extraction of ABCD parameters is a fairly easy system to implement and to use for patients as well as for physicians and medical practitioners. However, we have to be aware of the fact that the ABCD rule is not the end-all for cancer detection. As I mentioned earlier, there are several melanomas which can exist with diameters less than 6 millimeters and still be cancerous. This goes in direct conflict with what we learned with our ABCD rule, saying that melanomas usually exist with sizes greater than 6 millimeters. This type of melanoma, known as the nodular melanoma, is the most dangerous type of melanoma because it's very hard to detect using our current ABCD parameters. Keeping this in mind, we have now modified the ABCD rule to make use of another parameter known as the evolving parameter, which is used to monitor the change of our lesion. If there is any change in our lesion from when it was first present to the following weeks or time periods which precede it, if there is any change in the pattern, it could be a sign of melanoma, which is far more reliable than having to wait for it to reach 6 millimeters, by which time it could quite possibly be too late and be more invasive. Making use of the ABCDE rule would make this rule far more robust and accurate, as well as sensitive to the possible threats of other forms of skin cancer. Now, let me show you a demonstration using the MATLAB code which I have made. These are the MATLAB code scripts which I have implemented, of which these are the different scripts being used at the same time, of which I will run the main script, which will make use of to read any one of these images. For example, we shall make use of the benign. As we can see here, the algorithm has run its course and we have determined the A, B, C, D parameters and accordingly calculate the total dermatological score. And since that it is less than 4.4 less than our meter threshold, we can determine that the skin lesion is benign. Assuming that we take it for a malignant we see that we have calculated the A, B, C, D parameters yet again and found that the total dermatological score is 5.1578, which lies between the lower and upper bounds. So it's suspicious for cancer, so it's better that you get it checked out. That concludes my presentation. I hope I have met all of your queries and covered the topic well. Thank you.